All right, Unit 11 is all about three-dimensional figures. This section also covers their cross-section. Why don't we start by doing a little practice lesson on how to draw these, okay? So prisms have rectangular bases. So when you draw a prism, I want you to start by drawing a rectangle, okay? Does anybody have a request on a type of prism? Do you want a triangular prism, a square prism, a pentagonal prism? What do we want to draw here? Triangular prism. Thanks for speaking up. So now, since we've called it a triangular prism, the bases must be triangles. So I can draw this triangle many ways. I drew it like that. Notice it's a little skewed. Okay, that's because of perspective. We have any artists in here? You'll know about the parallel perspective and the diminishing perspective with parallel lines, and that's a fun little lesson to learn in art. Now, the next thing I need to do is just copy this vertical segment exactly how it is. I'm essentially creating a rhombus on the right side, or I'm sorry, a parallelogram on the right side. Now I connect the missing side, and that's a pretty solid piece of cheese. Is that a pyramid? It's not a pyramid. Most people think it's a pyramid. It's a prism with triangles as their bases, the triangular prism. Okay? Speaking of pyramids, let's draw one. So what are the lateral faces of a pyramid? They are triangles. Corey, what kind of pyramid do you want to draw? Triangular, square, pentagonal, hexagonal? A square. Okay, so now off the base, I need to draw a rhombus because a square in 3 dimensions looks like a rhombus. So I copy that segment over so that these two appear to be congruent. And then what I'm going to do is I'm going to dot one because if you can't see it, that doesn't look parallel enough for me. Well, hi, how are you?
Good, how are you?
Very good, thanks. But I'll just stick with it. Then I draw this shape, I draw that dotted line, and I draw that dotted line, and we have a decent square pyramid, okay? These dots are still called, does anybody know the name of the dots? Those are vertices, they're still called vertices. Does anyone know the name of the segments in a 3-dimensional figure? Starts with an E. Those are called edges. Okay? And then, does anyone know what the polygons are called in a 3-dimensional figure? The 2-dimensional sides. Those are called faces. So the next thing we're going to do, when I get off this slide, is we're going to learn about Euler's formula. But first, let's take a look at the patterns. This is kind of blurry because I blew it up so you can see it from where you're sitting, but we're making a table of vertices, edges, and faces for each one of these prisms. We got triangular prism, square prism, pentagonal prism, hexagonal prism. You can see there's a pattern. The more sides the base, obviously, the more faces it has. The more faces it has, the more vertices it has. The more vertices it has, the more edges it has. Euler came up with a formula for this. I don't memorize this. I truly don't know this because I can usually just figure it out. But it's faces plus vertices equals edges plus 2. So there are 2 more edges. Well, there are 2 less edges, I guess, than there are if you add the faces and vertices. Feel free to memorize that if you want, but I don't know if you'll have to. Okay, now we just want to show you about what it's like to intersect a 3-dimensional object with a plane. You're basically slicing it and looking at it. So does anyone have an intuition on if we cut this tetrahedron, so does anyone here play Tetris? What's tetra actually mean as a prefix? Does anybody know? What is every shape in Tetris has how many blocks? 4. Tetra is yet another prefix for 4, like quad, okay, or quart. So a tetrahedron has 4 faces. So this is a triangular pyramid, okay? If you sliced it, what shape would be produced? It's right here. What shape is this? It's a triangle. If you slice it parallel to the base, you're going to get an object that's similar, same shape, different size than the base. So if you sliced a square, if you sliced a pentagonal prism, you would get pentagons. Okay, a lot of times people struggle with this. This is calculus, so it's important for you at least to see it now. You're years away from calculus. But what if we took a triangle, isosceles triangle, and we spun it, but when we spun it, let's say like it created an aura where it added fabric. What shape would show up? That's a cone. Because when we spin it, it creates concentric circles. In fact, I didn't have another slide planned, but if I go back, oh, perfect. This isn't even from your slide, but this is how you draw a cone. Start out with an isosceles triangle that looks like you're going to draw a triangle. Draw an ellipse and dot the back. If you want to give it more perspective, you can do that again. And now you've got a more three-dimensional looking figure. Okay? Boom!